of both sides. So I have 4y is equal to 3x plus 12. I just put a 3x in front. Can I combine 3 and 12 to become 15x? No, not like times how we saw for y. Divide each piece by 4. So y is equal to what?
3/4 x plus 3.
3/4 x plus 3. If you have trouble solving for y, you need to come to either Stinger or after school because that is a lot of this unit, is solving for y. You did it a lot in Algebra 1, but you absolutely have to know how to do it in Algebra 2.
For find the vertex, you just look at the number to the right of the vertex and then the negative and then on the end.
For your vertex, I need opposite h, my k stays the same. This is h, this is k. It's already in vertex form, so Daniel, what's my vertex?
-3, -7.
-3, -7. That's from all the units we've done so far. Any questions? Very good. So, graphing lines. Y equals mx plus b, where n and b both have a name. This is algebra 1. What is the m? And y equals mx plus b. M is our slope. And b is the y-intercept. M is the slope, b is the y-intercept. So looking at number 1, what is my slope? And y equals -1/3 x plus 4. What's my slope? -1/3. And what's my b? Where do I begin?
4, 0.
At 4. Okay, my y-intercept is 4. So because I'm beginning at 4, I'm going to go to positive 4 and make my first point. 1, 2, 3, 4. Alright, my slope, I'm going down 1/3. So down 1, 1, 2, 3. Down 1, 1, 2, 3. 2 or 3 points should be fine just so you can make your line. But we know our slope is rise over run. If it's a negative, what do? Instead of rise, we go down, we fall. So if it's a negative slope, it is fall over run. That's what that means. Then I can just go ahead and connect my dots. Best as you can. It's pretty bad. That's my line. Number 2 is a little bit harder. I want you guys to solve for solve for y, and then tell me what your m and your b is.
Oh, wait, no, it's 2. -2.
Correct it to that, Daniel? Okay. So Daniel told us that our slope is 4/3, and our y-intercept is -2. Did you guys all get that? Your slope is 4/3. Your b is -2. So go ahead and plot those points. I'm going to start at -2 because that's my b, my y-intercept, and I'm going to go up 4/3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Is that what yours looks like? I'm going to connect my dots. So this part is a review of Algebra 1.
We also use a ruler to like connect the dots.
Absolutely. As long as it's kind of straight, I'm good. If you want to make sure it's perfectly straight, go for it. Alright, that was graphing lines. Graphing parabolas. I know it's going to be a parabola because parabolas are x squared. Okay? Lines are just x, parabolas are x squared. Let's find the vertex. Let's grab our calculators. In our calculators, we are going to type exactly what we see. -x squared plus 4x minus 3. Let's graph it and see what it's going to look like. Does yours look just like mine?
Yep.
If it doesn't, you probably forgot your negative. So make sure it looks just like mine. Okay, so we know that we can look at our table for the vertex, right? If we want to use our calculator for the vertex, what we have to do is look at our graph. Do I have a maximum or a minimum? Is it a high point or a low point on the graph? It's a high point, right? It's up top, everything else is below it. So I have a maximum. So let's hit second trace. Which one of these numbers do you think that we need for the vertex?
4.
Maximum, number 4. Do you see the little blinking Bob guy? I call him a few different things. So do you see the little blinker? Alright, so let's move left to right, whatever side he's on, so he's blinking at the very top of the graph. Let me know when you're there. Are you guys there? Gabe, you good?
2.
Okay. So sometimes, yeah, you're able to look at it and see, but you can use your calculator by going, it says left bound, I'm going to go 2 or 3 times to the left, I'm going to hit enter. I'm going to go back to the middle and wait for a second, it says right bound. We go 2 or 3 times, right? Hit enter. It's saying, should I guess? I want my calculator to guess, so I hit enter again. My maxima is 1.9999981. I can round that x to what? 2. So my maximum is what? 2, 1. Sometimes you can see it on your graph, but sometimes you can't, especially if it's a decimal. So we have 2, 1. Now, you're almost done, but not quite. Second table, let's just get a few points, just so I can get a visual here. So look at your table. You don't have to make a T-chart or anything. Just grab some points. My vertex is 2, 1, so I'll pick one above it, which is 1, 0. And then one below it, which is 3, 0. And then 0, negative 3. And 4, negative 3. So I just looked at my graph, got some points, and now I can graph it. Try to make it as round as possible. I want you guys to try number 4, but before you type in your vertex and do the whole maximum thing, can I tell what the vertex is for my equation?
Yeah.
What is it going to be?
-2,
-2, -4. You can still type it in and do the maximum or minimum, whatever you have. Go ahead and find some points and graph this. Alright, you guys get some points? X plus 2 squared minus 4. Graph should look like that. 0, 0, negative 4, 0.
I turned out as a straight line.
You know what?
My graph and that other straight line.
Number 4?
Yeah.
Did you do squared?
Mm,
Do zoom 6. Is it so straight?
mm.
It was probably just giving you one part of the line. Alright, so what I did was I just got 3 points, and then I just made my parabola. Alright, graphing circles. Let me know when you guys are there.
So there's my calculator won't do the graph.
What do you mean won't do the graph?
I would put it in.
Alright, so graphing circles. Next page. You guys there? I like graphing circles. I think it's easy. Here's our formula. Whenever you see an x and a y squared and an R2, or a number at the end, that tells you that it's a circle. Your first step is to identify the center, which is opposite of the numbers after x and y. Okay, in our vertex form, we always choose opposite h, same k. For circles, you take the opposite of both. And then you identify the radius, which is the square root of the last number. Square root of the last number. So the example, if you understand what's going on. Number 5 is x minus 1 squared plus y plus 3 squared equals 9. What numbers are following my x and my y? Negative 1, positive 3. I need the opposite of both of those. What is it?
1, negative 3.
1 and negative 3. So that tells me what my center is. It is opposite whatever is after the x and y. My radius I'm gonna be taking the square root of 9. What is the square root of 9? 3. So we have my center, we have our radius. Now I can graph my circle. Let's start with the center. Let's plot this point. 1, -3. So my center of my circle will be there. And because your radius is 3, you're going to go up, down, left, and right 3. So 1, 2, 3, make a dot. 1, 2, 3 to the right, make a dot. 1, 2, 3 below, make a dot. And 3 to the left. It is almost, or I think it's definitely impossible to draw a perfect circle. Okay? So just try the best you can. Try to make sure that they're all, I missed it by a little bit, but try your best. Don't make it a diamond. Don't make it a square. Try to make a circle. Easy peasy? Now on number 6, I don't have parentheses. I don't have a number following my x and my y, right? It is 0. So what that basically says is x plus 0 squared plus y plus 0 squared equals 25. It's the same exact equation. They didn't put the zeros because we don't have to. If I see something like this that is just x squared, y squared, what number is following that? What's my center? What's the opposite of 0? If you see just x squared and y squared without a number, then that means your center is your origin.
What happens if you can't square root your this r? Yeah.
You will always be able to. For the sake of this class, you will. But even if we give you like the square root of like 37 or like 38 or something like that, the square root of 38 would be like 6 point something, because 36 squared is, or square root of 36 is 6. So you can still do it, you'll just do like 6 point something. Does that make sense? All right, your radius for the square root of 25, what is it? It is 5. So let's start with our center, 0, 0. We're going to go 5 in every direction. I have a circle tool I'm going to start using because it makes my life easier to make the circle. You can just do your best. So that's what your circle should look like. Any questions? All right, let's move on to the next circle. I want you guys to do 7 and 8. Before we get started, what's the center of 7?
0,
1.
0, positive 1. And what's my radius?
4.
Right? Center 0, 1. Radius is 4. 1, 2, 4. 3, 4. Make sure your circles look like mine. So far, so good? Erica, how are you doing back there?
Good.
Alright, so this is the Algebra 2 part. Graphing systems of equations. A system of equations is a set of two or more equations using the same variables. When graphing system of equations, we are looking for the intersection of the graphs that are called solutions. We're looking for the intersections of the graphs that are called solutions. There are three options of graphs. How many intersections does this first graph have?
2, 4, 5.
None.
The first one? Is the parabola and circle touching at all? Is it crossing? No. So one option is no solution. How many times is my second graph touching? 2. So another option is we can have a number of solutions, whatever that number is. In this case, it is 2, but we're only talking about options. So a number of solutions. And the third one, it looks like just one parabola, but it's really 2. It's on top of each other. So how many solutions is that? Huh? You said all? Yeah. A better word is infinite. Infinite solutions. That means you can't even count. There's so many. Each point that it touches each other is a solution. So far, so good on this part? Lorena, what are you drawing? Are you done copying this?
Yep.
Okay. Alright. The first section here says, how many solutions does the following system of equations have? My question is, how many? So let's count. 1, 2, 3, 4. So I have 4 solutions. My second graph has how many? None. What about my third?
1.
It has 1. So we went from 4 solutions to no solutions to 1 solution. Looking for those intersections. Okay. What are the solutions of the following systems of equations? Now they're asking me what are they? They don't want to know how many, they want to know what the solutions are. Number 1, do I have any solutions? No, they're not touching. Number 2, what are my solutions? What's that point? Negative 2, 5. And what about this point here? 1, 2. So those are my 2 solutions for number 2.
Does number 3 have a solution since it just like touches and doesn't get through?
What does it have to go through? It just has to intersect anywhere.
0 and negative.
So it's still, so that one still counts. So my solution here is 0, -4. Did everyone understand Sam's question? Even though it doesn't go through the circle, it still touches it. So it's still the solution. So it's considered an intersection. I want you guys to look at the next one. Look at the graph system of equations and see if the solution is an intersecting point. Is 1, 3 a solution to the following system of equations? So look at number 1 and number 2. For number 1, do we think that 1, 3 is a solution?
Yeah.
We all agree? There's 1, 3. Are they intersecting there? Yes. So 1, 3 would be a solution for the first one. And for number 2,
No.
let's see here, 1, 3 is, right there's a point on my line, is that a solution? No. Just because it is on the line, it does not mean it's a solution. It has to be where the two are intersecting. Any questions? All right, so graphing systems of equations. There are many different ways to do this. You can do it by hand, which we've done. You can do it by looking at your factors, which we'll do later. Or you can do it by calculator. Okay, we're going to do it by calculator. In order to use the calculator to solve, you have to make sure it is equal to equal to y. Is this in y equals? No. So let's look at the first equation. Let's put the first equation, I'll solve it over here to the side. 3x plus 3y is equal to 18. How do I solve for y? Subtract 3x from each side. So we get 3y is equal to negative 3x plus 18. Then what? So what's my y equals? Plus 6, right? So they're all positive. So I did negative 3 divided by positive 3, so I got negative 1x plus 3. Which is solving for y. You can put this in your calculator and get points if you want. But I think that we can go ahead and just put this in ourselves. What's my slope here? Negative 1, basically over 1. What's my b?
6.
Your b is 6. So if you want to put it in your calculator and get points, you can. But I'm just going to go over here to b6. 1, 2, 3, 4, 5, 6. That's my y-intercept of positive 6. My slope tells me I'm going down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, the whole way. So down 1 over 1, there are my points. As I said, if you want to put this into your calculator, go for it. Do you have to? No. So we already graphed one line. Let's graph the other one.
Isn't there a thing where you plug in what you get for the first one and the second one?
But what'd you say?
Isn't there like a way to solve where you plug in what you got from the first one and the second one?
Yes, but that one's harder. That way it's much harder. So we're not doing it that way. Alright, let's solve for y. I have 5x minus 3y equals negative 6. What needs to go? So let's subtract 5x. Subtract 5x. So negative 3y is equal to negative 5x minus 6. We can't combine those because they're not like terms. Eric is telling us to divide each piece by negative 3. So we have y equals 5 over 3x plus 2. Alright, so once again, you can put this line in your calculator, look up your points. I think we can look and see what's my n.
Yeah.
5 over 3, and what's my b? Positive 2. So let's go ahead and plot. I start at positive 2, I'm going to go up 5, 1, 2, 3, 4, 5, over 3, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. There are my lines. That's a bad line. What is my intersection here? It's here, right? Looks like it's kind of in between 2 and 3 on my paper. What about yours?
Yeah.
Is it in between? So I think my solution is 1.5. 1, 2, 3, 4. This will be a great one to do in the calculator, honestly.
It says 1.5.
Did you use the intersect?
Yeah.
So you did negative 1x plus 6 in one line. The other line was 5/3 x plus 2. Make sure it looks the same. Okay, so I'm going to do second trace. I want the intersection, so that's 5. Oh, we're right. 1.5 and 4.5. That's my intersection. My solution.
One question.
Mhm.
So for the letter M, does it look like a negative 1 over 1?
It is. It's just your slope. You can just write negative 1 if you want, but we all know that it's 1 over 1. Like negative 1 over 1.
And the bottom looks like a 6.
Mm-hmm. Because mx, sorry, mx plus b. All right, so this portion we're going to be using all calculator, okay? For number 2, who said that? For number 2, our first step is to see, is this in y equals? Do I have both of these equations in y equals? Yes. I don't have to solve there. Back here, they were not in y equals. That's why we had to solve for y. But in this case, our work is done for us, okay? You can do this two ways. Let's pull up our calculators. And let's type in our first equation. You have y equals x minus 2. Oh, sorry. Alright, so x minus 2 squared plus 2. If I go to my table to get some points, just from looking at this equation, Daniel, what is my vertex?
2, 2.
2, 2. So let's just pick a few points above and a few points below. If you don't want to write the points to your paper, that's perfectly fine. I'm going to move it over here so you can see. So 2, 2, what I have highlighted here, that's my vertex. So we typically start there, and then we can just pick 2 points above, 2 points below. So 2, 2, and then 1, 3, 3, 3, 0, 6, and 4, 6. All I did was just get some points. Okay, that was pretty bad. I got some points and I graphed my parabola. Looking at that y equals 3, that should be pretty easy. That's an easy line to graph. If you want to put it in your calculator and get points, go for it, but we don't have to. If y equals 3, I'm going to make my point at positive 3 on the y-axis. Do I have a horizontal line or a vertical line?
Horizontal.
Horizontal, boy and bucks. So I'm just going to draw a straight line. There we go. We can tell what our solutions are from this. What are they?
1.
I have one solution there, which is 1, 3. My other solution is there, which is 3, 3. 1, 3, and 3, 3. Any questions on how we just did that? Just did all calculator. Need some water? Number 3, is it already on y equals? Yep, so most of our work is done. I'm going to type this into the calculator. I have y equals 2x, and then y equals x squared. Let's look at our table. Do you guys see how you have 3 columns here? What this means is, like x is the same for x and for y, which would be for that. Okay? That's my first equation that I put in. For y2, it's the same x, it's just I'm looking at that column for that line. Does that make sense? If that confuses you, just put them in one at a time. So I'm going to go ahead and graph them. My red one, I'm looking at, sorry, it's a little confusing. It's red. I'm looking at those two, x and y. So let's see, 0, 0, that looks good. -1, -2, -2, -4. And I'm just looking at my points and I'm just plotting some. 1, 2, that's enough. That's enough for my line. And I can go ahead and I just draw my line. I got the points, now I'm drawing the line. For the next one, I'm looking at this x and y2 for my second equation. So we still have 0, 0. And then we have 1, 1. So now just kind of block this out. Erase it. You don't even need it. 1, 1. 2, 4. Negative 2, 4. Negative 1, 1. Do we see my parabola here? Yes?
Yeah.
Now, I think one of these is very easy to see. Which solution is very clear? Which one is very clear? Where they crossing? Right there, goes at the origin. 0, 0, we can all see. That other point, I'm not too sure. Let's look at my graph. Now to find the intersection, did everyone type this into their y equals already? Make sure it's in there. If I want to find the second solution, I'm going to go to second trace. Which of these words means intersection? Solutions.
0.
Number 5, intersect. Alright, we know that one's 0, 0. I'm pretty confident with that. This one up here, I don't really know. So I'm just going to put the little blinking bob guy on that intersection. And my calculator says first curve, I'm going to say yep. Second curve, yep. Should I guess? Yep. What does it say our intersection is? 2, 4. So for all of these, if you wanted to, you could just type them into your calculator, look up some points, and then use your features to find the intersection. Second trace. Any questions? All right, let's look at number 5. Are they already in y equals?
Yeah.
Yep, life is easy. Because they're already in y equals. This y equals x minus 4. That's a line, right? What's my n? 1. And what's my b? Negative 4. You can plot this if you want to. Gabe, what are you doing? But this is just a line. You can just start at negative 4, 2, 3, 4, and your slope tells you to go up 1 over 1. I think it's much easier to just graph it this way. Than to look up points in your table. The second one won't be as easy, but what's our vertex going to be?
None. Wait, there's,
For the first right. What is it?
0, negative.
No. Where this one?
Negative 1, 2.
Negative 1, 2. I can't tell what my vertex is. There actually is no vertex for a line. So, for the first equation, my vertex is negative 1, 2, which is there. Now let's get some points. Make sure you clear out your calculator every time. So I have x plus 1 plus 2. And then I'm going to look at my table and get some points. I know that my vertex is negative 1, 2, so let's just pick a few points above and below. Negative 2, 3. Negative 3, 6. Do the same thing on the other side. What's my solution? None. They're not intersecting at all. On your test or something, if I say like number 5 with the same problem and then solutions without a graph, you don't have to graph anything. But if there is a graph, you need to be able to sketch your graph. All good, number 5? All right, let's look at number 6, last one. I know I have a line and I have a circle. I know I have a line because it's just y equals 4, so that's linear. And then x squared and y squared, if I see those two together, I'm thinking circle. So I have a line and a circle. Do I need to plot and get points for y equals 4, or can we do this one? We can just do it. My y is negative 4. Sorry, positive 4. 1, 2, 3, 4. We put a dot there. And then you're going to draw a horizontal line because it is y equals. It is 40. For the circle, you could solve for y if you wanted to because it is not in y equals. That circle is not in y equals, but that's going to be more difficult. What's my center of the circle? 0, 0. What is my radius? I can just graph that, right? My center is at 0, 0. My radius is 5 all the way around. 1, 2, 3, 4, 5, 5, 5, and 5. I'm going to use my tool to match the circle, so you guys just draw them the best you can. How many solutions do I have?
2.
I have 2. I have one solution here and one solution here. So Daniel, give me a solution.
Negative 3, 4.
Negative 3, 4. Lorena, give me another solution. He already gave us negative 3, 4. What's another one?
Positive 3 and 4.
Positive 3, 4. Are there any questions on this? All right, your homework is homework B, front and back. You have about 10 minutes. Go ahead and get started on it. If you notice on your assignment sheet, you have a mini quiz next class on day 1 and day 2.